I'm a student teacher. I'm coming to teach you all about family functions, discrete versus continuous. And okay, that's good. Discrete. Who would like to volunteer and read discrete for me? Go ahead, sir.
A discrete function slash graph only consists of certain distinct points that can be counted or listed.
For instance, the number of students in a classes throughout the day is a discrete function. You can't have half a student. Like, I can't say like I'm a whole body, but I'm half of a person. Like, it can't be half of a person. It has to be a whole person. Okay. Examples. The number of people in your class, no fractional parts of a person, like I just stated, and the number of TV sets in a home. So, does anybody have half a TV in your house?
Yep.
You have half a TV. You can't have half a TV. You have to have a whole TV, okay? The number of puppies in a litter, no fractional puppies. Like, my mom's dog just had puppies, so it didn't come out half a dog. It came out a full dog, not half a dog. Okay? And the number of questions on a math test, no incomplete questions. Like, when Ms. Tollett is giving the test, she doesn't have the boy went, because you're going to be like, the boy went where? Like, that's not the whole question. Okay. Would anybody else like to read? Okay.
Always remember, discrete data is counted. The description of the task is usually preceded by the word number.
Okay. Function. In the graph of a discrete function, only separate, distinct points are plotted, and only these points have meaning to the original problem. Graph. A discrete graph is a series of unconnected points, a scatter plot. So it'll look scattered on the graph. I'll show you that in just a second. So now we're moving to continuous. So anybody like to read continuous? Okay, sir. Yes, continuous.
A continuous fashion class graph consists of all points within a given interval, including up to infinity.
Okay. Like on and on and on. It just keeps going on and on and on.
Okay.
For instance, the height of a student in my classes throughout the day is a continuous function. It can have a decimal answer. Another way to think of continuous is, did I have to pick up my pencil in the drawing of a graph? Would somebody like to read the examples for me? You can read it, sir.
The height of a horse could be any value within the range of horse's height. Time to complete a task, which could be measured to fractions of seconds. The outdoor temperature at noon, any value within possible temperature ranges. The speed of a car on Route 3, assuming legal speed limits.
Okay, always remember, continuous data usually requires a measuring device. Ruler, stopwatch, thermometer, or speedometer. Anybody want to read the functions?
In the graph of a continuous function, the points are connected with a continuous line, since every point has a meaning to the original problem. Domain, a set of input values consisting of all numbers in an interval. A continuous function allows the x values to be points in the interval, including fractions, decimals, and irrational values.
And this is an example. It says, is it discrete or continuous? The answer is neither. Neither. We can also have neither discrete or continuous. This occurs when our graph jumps points, which makes it not continuous, but has possible decimal values, which makes it not discrete. So you will see the discrete and you will see the continuous graphs. Intercepts, where the graph crosses the axis. X-intercepts where the graph crosses the x-axis, y equals 0. Y-intercepts where the graph crosses the y-intercept, x equals 0. And this is a quick video, Ms. Payne, if you don't mind playing it for me.
This video explains discrete and continuous functions. A discrete graph or a discrete function has values. They can only take certain values. Okay, so that seems really strange and I didn't really write that very well. But what I mean by it is it can only be certain types of numbers. I'll give an example. If I said our function is like how many students I can have in my class. Well, I can only have positive whole numbers as the values that I can have, because I can't have 1.5 students in my class or 3.75 students in my class. So in that case, in that example, it could only be positive numbers. The graph would look like isolated points. So this is an example. See how these points are just there, they're not all connected with a line. So this would just be 0, 1, 2, 3, 4, 5, 6 as the axis. So when you look at the domain of this graph, it would just be individual values. So we would say the domain of this is 0, 1, 2, 3, 4, 5, and 6. That's the domain. So here's some other examples of discrete. So if you know the number of stories in a building, then you know the height. So there's no like decimals, there's no in between, there's no 1.5 stories, there's no 3.75 stories. So this function will be discrete. The same with this example is museum tickets and total cost. Well, in this example, like, you aren't gonna buy like 5.5 tickets or 1.25 tickets. You're gonna buy whole numbers of tickets, and it's gonna cost a certain amount of money. Even though this money can be decimals, our x values are all whole numbers, so then this is a discrete function. Continuous is pretty much the opposite of that. So continuous values could take any value. So it can include, in this case, like, let me give you an example. What if I was talking about the height of my students? Well, when we all measure our heights, it can be any value. It can be a decimal or a fraction or what have you, because not everyone is just 5 feet or 6 feet. The graph, when you look at it, it's unbroken. It's a solid line. So basically a continuous graph you could draw without picking up your pen from the paper at all. So that's what a graph of a continuous function looks like. So the domain of a graph like this would be written a little bit different, because it actually has an entire range of numbers. It's not just 0, 1, 2, 3, 4, 5, 6 like the last one. In this case, my domain would be that x is greater than or equal to 0, and I know that it's greater than 0 because it's going to be bigger than 0, but it's also equal because this is enclosed in a circle.
Okay, so now I'm going to give you like a little short quiz of this to make sure you understand what was being said today.